So for today's video, we are solving of the application of derivative into velocity, acceleration, and rectilinear. So we are going to solve this problem. So as the derivative of starting point is the velocity. So now we have this equation, which is s is equal to negative 16t squared plus 64t. So to find the derivative, just simply using the power rule, negative 16 times 2t plus 64, the derivative of 64t is 64. So now multiply negative 32t plus 64. So the first question is, find the instantaneous velocity of the ball at the end of 1 second. So at the end of 1 second, so we will use this equation, our velocity at 1 second. Time is equal to 1 second. So velocity is equal to 1, using this equation, negative 32t plus 64 is equal to negative, substitute t as 1 plus 64, we'll get a 32. Now the unit is feet square per second. Now since the outcome is positive 32, and the follow-up question is the ball rising or falling at the end of 1 second? Since we get the positive outcome, so therefore the ball is rising. So next question is, find the instantaneous velocity of the ball at the end of 3 seconds. So we still use the derivative form, then substitute the 3, then 32 times 3 is 96 plus 64, so we'll get a negative 32. And the follow-up question is the ball rising or falling at the end of 3 seconds? So now that we get a negative outcome, and the negative outcome is the ball is falling at the end of 3 seconds. And so don't forget the unit of feet, 32, negative 32 feet per second. So the third question is, how many seconds does it take the ball to reach its highest point? So we are finding the time of how to reach its highest point. So let's say a is equal to 0, or the acceleration is equal to 0, is equal to, use the negative 32 or the derivative form of the starting point plus 64. So we'll say a is equal to negative 32t plus 64. So subtract both sides by negative minus 64 minus 64. So we'll get a negative 64, 32, negative 32. So divide both sides by 32, negative 32, we cancel negative. So we now have a t is equal to 2. Now to reach the highest point is, it's say 2 seconds is the highest time to reach its highest point. And then the fourth question is, how high will the ball go? So we will use this 2 seconds to find how high the ball go. So we will use the equation of the s is equal to negative 16t squared plus 64 t. So our time s is equal to 2, then substitute t as our 2 squared plus 64 times 2 is equal to negative, so we'll get a negative 64 plus times 2 is 128. So add, we'll get a 64 feet to reach. So the highest point the ball go is 64 feet. So the fifth question is, find the speed of the ball at the end of 1 second and at the end of 3 seconds. So to find the speed of the ball at 1 second, we'll use the derivative form then t is equal to negative 32 t plus 64. So substitute our t is 1, negative 32 times 1 plus 64. So we'll get a 32 feet per second. So how about the speed of the ball at the end of 3 seconds? So we will use this equation. So s is equal to negative 16 t squared plus 64 is equal to s t negative 16, since we will use the 3 as the end of 3 seconds. So our t will be 3. T is equal to 3. So 16 times negative 3, negative 16 times 3 squared plus, forgot the t, 64, 3. So 3 squared times negative 16, so we'll get a 144 plus 64 times 3 is, I forgot the negative sign, 144 plus 128. So add, we'll get a negative 144 plus 128 is 16 feet per second. So that is the speed at the end of 3 seconds. So the next question is, how many seconds does it take the ball to reach the ground? So to reach the ground, so we will find the time at the starting point. So s is equal to negative 16 t squared plus, I forgot the t, 64 t. So let's say 0 is equal to negative 16 t squared plus 64 t. So we can factor out this equation. So let's t multiplied by negative 16 rather, t plus 64. So if we multiply these terms, we'll get this equation. So let's say t is equal to 0, and we will find the second does it take the ball to reach the ground. So we will find the t, the second, by using this. Let's say negative 16 plus 16t plus 64 is equal to 0. So subtract both sides by 64, negative minus 64 minus 64, so we'll get negative 64, then negative 16t, then divide both sides by negative 16, so our t is equal to 4. Cancel out, so our t is, first our t is 4 seconds to reach the time of does it take the ball to reach the ground. So last and final question, find the instantaneous of the ball when it reaches the ground. So by using this time and using the derivative form to find, v is equal to negative 32 t plus 64, and our t is 4 seconds. V is equal to 4 sec t, where's our 4, then substitute negative 32 times 4 plus 64, so we'll get the 128. Negative 32 times 4 is 128 plus 64, and then add, so we'll get the negative 64 feet per second. So the instantaneous velocity of the ball when it reaches the ground is negative 64 feet per second.